In this video, we'll talk about atomic interactions, including covalent bonds. Now that we've learned about atoms and elements, let's talk about how these atoms interact with each other. A molecule is defined as two or more atoms linked together through covalent bonds. A chemical compound is a molecule with two or more different elements. A molecule could be something like oxygen gas. However, a chemical compound would be something like water. It is a compound of hydrogen and oxygen atoms covalently bonded to each other. The chemical formula for water is H2O. As we start talking about atoms and molecules, we're dealing with physical systems. And there are a few concepts within physical systems that are important to understand to figure out how atoms will interact with each other. And so the first physical concept is that systems try to move to where they are most stable. And so chemical bonds and chemical interactions will occur to result in the most stable system possible. Another concept in physics is that when dealing with electrical charges, opposite charges attract and like charges repel. Another interesting dynamic of electrical charges is that electrically charged objects are more likely to interact with each other, whereas uncharged objects, or objects which are electrically neutral, they will not want to mix with objects that have electrical charges. So to understand why this is significant, we need to start looking at electron shells. Now, electrons are held in these shells, also known as orbitals, which orbit around the nucleus of an atom. This is a simplified view of how the atom works, but it's sufficient for what we need to understand as far as this fundamental biology is concerned. Atoms are going to be most stable when their outermost electron shell is filled. Now, as far as the atoms that we'll be discussing, we'll only be looking at the first three electron shells, or orbitals. The first electron shell can hold exactly 2 electrons, whereas shell 2 and shell 3 each can hold 8 electrons. In order to fill these outermost electron shells, sometimes atoms will share these electrons in these outer shells with each other in order to have a stable outer shell. Covalent bonds involve the sharing of electron pairs, with one electron of the pair coming from each atom. Covalent bonds will form until each atom has a filled outermost shell. As I had mentioned, the first electron shell can hold exactly 2 electrons, whereas shell 2 and shell 3 each can hold 8 electrons. Different atoms and different elements will have different numbers of open spots in their outermost electron shell. If they meet a few criteria, those atoms can participate in a covalent bond by contributing 1 electron to the pair while receiving an electron from a neighboring atom. Once these two atoms are sharing a pair of electrons, they must be held close enough together that the electrons can orbit around either atom, and this is what a covalent bond is. Now, certain atoms are capable of sharing up to 4 electrons, or forming 4 covalent bonds. This all depends on how many open spots they have in their outermost shell. If we are given the atomic number of an atom, that tells us the number of protons in that atom, and it also tells us the number of electrons because these atoms are electrically neutral in their base or elemental state. With this information, and knowing how many electrons fit into each of the electron shells, we can figure out how many empty spots there are in an atom's outermost electron shell, and this in turn can tell us how many covalent bonds this atom may be capable of. For instance, hydrogen has the atomic number of 1, means it has 1 proton and 1 electron. That electron is in a shell that has room for a total of 2 electrons. So hydrogen has 1 empty spot. It's willing to share the 1 electron it has in order to fill that empty spot, and so hydrogen atoms are capable of forming 1 covalent bond. Carbon atoms have the atomic number of 6, meaning they have 6 protons and 6 electrons. The first electron shell holds exactly 2 electrons, meaning we have 4 electrons remaining in a shell that has room for 8. In this case, carbon has 4 outer electrons which it's willing to share, and 4 spots which it's looking to fill, and so carbon can form a total of 4 covalent bonds. Now let's look at oxygen. Oxygen has the atomic number of 8, meaning it has 8 protons and 8 electrons. The first 2 electrons fit into shell 1, leaving us with 6 electrons to go into shell 2, a shell which has a room for 8 total electrons. This means that there are 2 empty spots in the outermost electron shell for oxygen. Since there are more than 2 electrons in oxygen's outermost shell, it has the ability to share some of its electrons in order to fill empty spots in its own shell. And for this reason, oxygen is capable of forming 2 covalent bonds. So different elements can form different numbers of covalent bonds depending on their starting number of electrons. We'll talk more about the different types of covalent bonds in the next video.